Hello everyone, hope all are doing good, and I am here with the second video in the motor controls. I am going to explain about the relay and contactors in the motor controls. So first see, what is relay? A relay is a switching device. It can be electromechanical switch or it can be a static switch as well. So based upon the construction, we can have different types. Okay, also used for different purposes. Okay, here basically what it consists of is we have a iron core and we have a coil wound on it. So when you supply the coil with electricity, it produces the electromagnetic field which pulls the armature so that it can either make the circuit or it can break the circuit. So if you have connected the output in NC and common terminal as input, so it will break the circuit. In vice versa case, if you connected the input in common and your output terminal is connected with NO, so in that case, when you energize the relay, it makes the contact or it closes the circuit. It allows some operation to takes place. It is very simple. It is single pole, double throw. So we have NC type as well as NO type contact. So based on the wiring, so either it may open the circuit or it may close the circuit. The basic difference is in the normal switch, there is a mechanical arrangements. When you operate it, it latches the switch and it closes the electrical path if it is a dead end type. If it is a push button type, it temporarily closes the contacts and it allows the current flow, or in vice versa, it breaks the contacts. But here we need to give the electrical supply to the coil, produce the flux, and because of the flux, the armature will be pulled. So this pulling action will lead to either close or open the circuit. Why we are discussing about this? Because this is very important to understand the contactors, so which is a very essential component of any motor controls. Let us go into the contactors. So in a contactor, we will have a different arrangement to produce this magnetic field. Not like a relay. The relay will have a smaller armature and it will pull or it will break the contact easily. But in the contactors, so you need to produce a strong magnetic field, and the coil which is wound on that also will produce a magnetic field, strong magnetic field. And these methods which I have shown here will help to reduce the resistance or the resistance for the flux movement. These are the different arrangements used for producing the electromagnetic field so that it can attract the moving contact so that it can close the circuit or it will break the circuit. So internally it looks like this. So here we have the core where we are going to wind the coil, and this part is a movable part. So when you give the supply to this coil, so where the coil is going to produce electromagnetic field, so because of that this core here is going to move upwards. When it move upwards, so what happens, actually these contacts whatever I have shown here also go up and it makes the contact to be closed. So here in L2, say for example in the top you give the input terminal and you take the output terminal from the bottom. So when this electromagnetic field pulls this core and when this goes up, so these two contacts are going to be closed, and that means the current is going to flow from the input terminal to the output terminal and it goes to the rest of the your circuit. So it may be a solenoid or it may be a coil or it may be a motor or whatever the load you have connected there, it is going to be the current flow is going to take place if all the other switches are closed. Okay, so what is the difference between these relay and contactors? So the relays are mostly used with the low power devices and for some control actions and producing the logics, something like that. But the contactors are used for connecting the heavy duty loads like a big motors, motors, and sometimes we connect this one to big solenoids, something like that. So mostly we use these contactors for connecting the motors, that is heavy loads. So this is the basic difference between the relay and the contactor. So based on the need, the contactors has more contacts. In sometimes the relay also has more contacts, but mostly the contactors will have more contacts than the relay. The physical appearance of these contactors are like this. So you can see here. Okay, so we have the contactor part. So this is a contactor part, and this is a overload relay part. I will explain about this overload relay in the next video. So this top part is a contactor. So we have here main contacts as well as auxiliary contact. So this is auxiliary contact, and we are having here the main contacts. So in the main contact, you can see here three input terminals and three output terminals. So that means L1, L2, L3 of a input supply can be given here, and the output is given to the overload relay. From the overload relay, it will be connected to the motor. Okay, and this is for the power circuit. So when you need to connect a like an indicator lamp and for some control purpose, for latching circuit and kind of things, you need a auxiliary contacts as well. So these three contact is not enough for making the contact control circuit. So we have the auxiliary contacts. So where I have a two NC and two NO contacts. Okay, so these NC and NO contacts are mostly used in control circuit. So auxiliary contacts are used for auxiliary circuits, sorry, control circuits, and the contactor, the main contactor, is used for connecting the load or a power circuit. Okay, so if you have, say for example, the same motor, but you have a forward and reverse control, you will use two contactors. In case you have just on off of a machine, like a DOL starter, direct online starter, so you may have on and off a push button, and when you press on push button, so the motor, the relay coil, the contactor coil get energized, and you will use auxiliary contact for latching, and the contactor will be kept in on condition even you release the hand from the push button, and the motor keeps running until otherwise you press the off push button, or the overload relay opens the circuit with the overload condition. Okay, in case if you have the same motor with forward and reverse control, then you will have a two contactors, one for forward and one for reverse. So if you have the same motor like a star delta, okay, star delta purpose, so you will have one main contact, okay, one contactor for star, one contactor for delta. So you will have a three contactors for the same motor to run the motor in a star and a delta connection. So based on the requirement, the contactor numbers may be increased. Okay, so the symbol or the switches, the contacts is shown here. So it will be like a capacitor symbol. So where you will have two terminals. So this is the NO terminal and NC terminal also available. If you put on a cross line here, it will be NC terminal. So this main contactor, we have three terminals, and three terminals are represented here, L1, L2, L3. So if you give the input from here, yeah, so if you give the input from here, so these contacts will be closed, and it will go through here and it will come out here. So that means the supply, line 1 supply will be given here, and the T1 will be connected to the motor coil. Okay, so something like that, and again here from L2 the supply will be given, and the T2 will be connected to the motor. How we are going to represent the contactor? So the contactor coil is represented in this way. So we will have a round or a circle with two lines in both direction, and we have a stop switch and a start switch. So this particular control circuit represents a DOL starter, or you can say, yeah, with the indicator lamp. So what happens here when you press the start push button, the circuit is getting closed here, something like this. Say for example, when you press the start push button, the circuit is getting closed here like this. So the current flow goes through this coil. So this coil, when it is getting energized, so this contact will close like this. When this contact is closed here, simultaneously this contact will open. So that means there is no current flow to the pilot light. So at this moment, even if you release your hand from the start push button, the current will break here. The current will break here. So there is no current flow through the switch, but the current flow is going through this path, so that the coil is getting supply and it is still in the energized condition, so that the contact of this particular coil will be in closed condition. Here this contact will be closed, and it goes until you press the stop push button. So if you press the stop push button, the energy or the supply will be broke from here itself, so that the coil will not get any energy and it will get de-energized, so that now the the latching also will be broken, and at the same time here the NC contact will come to normal state, so the pilot light will be in on condition. Okay, so this is for L1 and the L2 bus bar. So the starting takes place from L1 and the end will be in L2 bus bar. So this is how the control circuit will be represented. Thank you. Hope you understood what is a relay, what is contactor, and how it is represented in a motor control circuit. Thank you. Thank you for watching.